Hello everyone. You are on the Java Rangers channel. My name is Olga. Today I will tell you how to perform migration to a MongoDB database using the MongoG tool. So, what is MongoG? This is a data migration tool based on Java that is used to perform safe migrations in distributed systems. It allows developers to manage data migrations during the application deployment process, ensuring the coordinated delivery of code and data changes. That is, when we are developing an application, we need to have some data in our database, and I will now tell you how to populate the database with test data. So, let's create a project using Spring and Schweitzer. We'll choose a Maven project in the Java language. Spring Boot version 3.3.2, which is the latest release. Let's change the name to Mongo Demo Project. So, we'll leave everything as it is and add all of the necessary dependencies. Let it be Lombok. Spring Web for now. So, we downloaded our archive, unpacked it, and opened IntelliJ IDEA. The first thing we need to do is add the necessary dependencies to the POM file. So, let's see what we already have here. This is the Spring Boot Starter Lombok Spring Boot Starter test. In addition to the dependencies we already have, we will add 3 more dependencies. This is primarily a dependency for MongoDB, for working with the MongoDB database, and 2 additional dependencies that are necessary for working directly with Mongo. As of today, the versions are 4.3.8 and for MongoDB 3.3.2. Next, I created the user entity. It is the user that we will be writing to our database. Here, the class has 2 annotations. The document annotation indicates that we will be writing to the MongoDB database in a collection named users, and there is a required arguments constructor. There are 3 fields here: a private object ID with ID annotation, a private string name, a private string email, and a getter and setter. Now I have created a changelog folder. Yes, I exclaimed about the script rules, email, as well as getters and setters. Now I have created a very interesting folder. In the changelog folder, I created the database changelog class. This code represents a database changelog class, which is used to manage changes in the database using the Mongo library. Let's break it down into parts. Changelog annotation. It indicates that this class contains changes to the database. The cDatabase method, annotated with change set, which means that this change will be applied to the database. Annotation parameters. Order is equal to 001. This is the order of execution of changes. ID is equal to cDatabase with users, a unique identifier for the change. After me is the author of the change. Method body. The method takes Mongo template as a parameter. A list of users, user list, is created. Then, 2 user objects are created with the names and email addresses, Peter and Fyodor. These objects are added to the user list. At the end, the list of users is inserted into the users collection in the database using Mongo template. This method is intended for the initial population of the database with users. Now we go to the application properties file. This is our path to the database. Earlier, I created a cluster on the Atlas resource and added its URI here. I specified it in the environment variables. The name of the database, I named it demo data. The package that contains the changelog. For me, it is changelog. Now we go to the main class that launches the Spring Boot application. There is one very important annotation that we need to add here. It is enable Mongock. This annotation allows you to run Mongock, the database migration, when the application starts. That's it. Now you can run the application. Our application is running in the logs. We can see that changes have been applied to the database. Let's check. Here I opened the MongoDB Compass program. I'm updating it, and now we see that the demo data database has appeared, and it contains 3 collections. The users collection, which contains our 2 users, Piotr and Fyodor, everything as we expected. There are also 2 more collections, Mongo log, it is empty, and Mongo changelog. All changes are recorded here when the database is all started. If we run our database again next time, MongoG will check this Mongo changelog collection again. If there is a record with this change ID in the system, then next time it will not write the data. Alright, we have essentially and completely filled the main database system, but what does test mean? Similarly, using MongoG, we will perform all the same operations to populate the test database. However, I will be creating the test database locally instead of on a remote server. I created the application properties file in the resources folder in the test. Here I actually copied all the same 3 lines, but the data needs to be changed. So, here, as I already mentioned, there will be a local database at localhost 27.0.17. Here I changed the name of the database to test data. Here I left the same package right over here for scanning purposes. You can create a different changelog for the test database, but I left it the same. We remember that I added the Enable Mongock annotation under the application logo so that the database migration would start with the application launch. Now, in order for the database migration to run with the test execution, we need to add this annotation to the Mongock demo application test file. Now I have created a test class that contains tests for the user repository. The Spring Boot test annotation is used to create a fully configured instance of the application context for testing. The context is Spring for fixing. The user repository test class is a test class that contains tests for the user repository. The auto-wired annotation is used for the automatic injection of the user repository dependency into the test class. The test user repository method is an annotated test, indicating that this is a test method. Inside the method, a call to user repository findAll is made, which returns a list of all users. Then, using the assertion assert equals, it is checked that the size of the user list is equal to 2. This test checks that the user repository contains exactly 2 users. Let's run it. The test was successful. Just to be sure, let's take a look at the database to confirm that our 2 users are there. Here, everything is fine. The database was created when the tests were run. Here are our 2 users and an entry in the changelog. But let's imagine a situation where our test checks not for the presence of users in the database, but creates new ones. What will happen in the case of repeated test runs? Naturally, the test will fail because the number of records will keep increasing. After all, our database is not cleared after the tests are run. For this purpose, I created a method called cleanup with the afterAll annotation, which means it will be executed after all tests in the class. Here's what it does step by step. This code, Mongo client, creates a connection to the MongoDB server running on the local host at port 27017. Next, the Mongo database. Here we access the database named test data. Next, there is a loop that goes through all the collections in the database and deletes each one of them in the database. A message is printed to the console for each remote collection. At the end, the method closes the connection to MongoDB. Thus, this method cleans the test data database after all tests have been executed by removing all collections within it. There is one more thing that needs to be considered. By default, the method marked with the afterAll annotation is static. To make it non-static, I use the test instance annotation above the class. Test instance, lifecycle, per class. But don't you think that the process of running tests can be optimized? If we have many test classes, the cleanup of the test database will occur in each of them. But how can we ensure that the database is cleared only once after all tests are completed? The answer is very simple. We need to move this method, cleanup, from here to here, Mongo demo application tests, and don't forget to bring this annotation with you. It's no longer needed here. Alright, let's try running the tests. This is exactly what was needed. All tests passed successfully, and in the end, we see that all collections in the database have been deleted. Thus, today I told you about one of the ways to populate a MongoDB database. We were assisted by MongoG, as well as its automatic cleanup feature. Thank you.